Welcome to our deep dive into disease propagation simulations. Today we'll explore how these simulations work and their importance in understanding and controlling disease outbreaks. You know, disease, it's a real party pooper. But luckily for us, scientists have these amazing tools, almost like crystal balls, that help us understand how diseases might spread. They're called disease propagation simulations, and they're like video games that help us stay one step ahead of those pesky germs. Get ready to explore the fascinating world of disease propagation simulations. Imagine a disease propagation simulation as a giant, intricate stage play. Now, the stars of our show aren't your typical actors. They're called agents. Think of each agent as a digital representation of a person, just like you and me. Each agent gets its own unique set of characteristics. We're talking age, health status, maybe they love going to crowded concerts, or maybe they're homebodies who prefer a quiet night in. You see, these details matter. They all factor into how our agents interact with each other and the world around them. Now, let's say Agent A loves to party and Agent B prefers staying home with a good book. Who do you think is more likely to catch a cold going around? That's right, our social butterfly, Agent A. But don't worry, we don't leave our agents to fend for themselves. We give them tools to stay healthy. Some agents might be wearing masks, diligently washing their hands, or even getting vaccinated. It's like giving them tiny shields and swords to fight off those invisible villains we call viruses. And just like in real life, these choices have consequences. An agent who always forgets to wash their hands? Well, they might be more susceptible to catching whatever's going around. It's all about cause and effect, my friends. Alright, so we've got our agents, each with their own quirks and habits. Now let's talk about where they live, their environment. Just like a real city or town, the simulation environment plays a huge role in how our story unfolds. Think about it. A bustling city with people packed like sardines is a much different playing field for a virus compared to a quiet village in the countryside. We're talking population density, my friends, the number of people crammed into a particular space. More people mean more opportunities for our sneaky virus to jump from one unsuspecting agent to another. It's like a game of tag, but with much higher stakes. But wait, there's more. Our environment isn't just about crowds. We also factor in things like hospitals, clinics, and the availability of doctors. A top-notch healthcare system can be a real game changer. It's like having a superhero team on standby, ready to swoop in and help our agents fight off infections. And let's not forget about geography. Is our simulation set in a place with long, harsh winters? Well, that might make it easier for viruses to spread as people huddle indoors for warmth. You see, the environment is like the backdrop of our play, influencing every twist and turn of the plot. So, we have our agents, each with their unique characteristics, living in their carefully crafted environments. Now let's talk about what happens when these two worlds collide. Interactions. This is where things get really interesting. Our agents aren't just standing around like statues. They're constantly on the move, interacting with each other and their surroundings. Some agents might bump into each other at the grocery store, while others might share a laugh on a crowded bus. Each interaction, no matter how fleeting, represents an opportunity for our virus to spread its wings, or shall we say, its microscopic tendrils. Imagine Agent A, our social butterfly, deciding to go to a concert. They're surrounded by hundreds of other agents, all singing along to their favorite band. Now, if just one of those agents happens to be carrying the virus, well, it's like popping a confetti cannon full of germs. It only takes one infected individual to set off a chain reaction, like a domino effect, spreading the virus far and wide. But remember those preventative measures we talked about? This is where they come into play. An agent wearing a mask at that concert, they're like a force field, reducing the chances of those virus particles getting through. It's a constant battle between our agents and the invisible enemy. Now, you might be thinking, Bill, this is all starting to sound a bit chaotic. And you'd be right. It kind of is. But don't worry, there's a method to the madness. Behind the scenes of our disease propagation simulation are a set of rules, like a highly sophisticated instruction manual that keeps everything running smoothly. These rules are based on real-life scientific data and mathematical models, carefully crafted by epidemiologists and statisticians. We're talking about things like the probability of infection based on contact with an infected person, Is a simple handshake enough to transmit the virus, or does it require a more intimate exchange, like a cough right in the face? Our rules take all of these factors into account. Then there's the effectiveness of interventions. How well does wearing a mask actually protect against infection? What about social distancing? Do these measures make a difference? Our simulation crunches the numbers using real-world data to give us the most accurate picture possible. And of course, we can't forget about the duration of infectiousness. How long is an infected agent contagious? A few days, a few weeks? These are all crucial pieces of the puzzle that our rules help us understand. Okay, so we've got our agents, our environment, our interactions, and our rules. Now, for the moment of truth, running the simulation, this is where the real magic happens. By setting all these parameters in motion and letting the simulation run its course, researchers can observe how the disease spreads through our virtual population. It's like hitting the play button on a time-lapse video, watching as the virus jumps from one agent to another, creating clusters and outbreaks. But it's not just about watching the chaos unfold. Disease propagation simulations allow us to answer critical questions. Where are the high-risk areas? Which groups are most vulnerable to infection? What happens if we implement a mask mandate or encourage more people to get vaccinated? It's like having a crystal ball, giving us a glimpse into different possible futures. This information is invaluable for policymakers and public health officials. They can use it to make informed decisions about resource allocation, vaccination strategies, and public health messaging. It's about being proactive, not reactive, and using the power of science to stay one step ahead of the next outbreak. Thanks for joining us on this journey through disease propagation simulations. Stay curious and keep exploring the fascinating world of science. Remember, these simulations are powerful tools that help us understand and combat the spread of diseases. They're a testament to human ingenuity and our constant quest to unravel the mysteries of the natural world. By harnessing the power of science, we can create a healthier and safer future for everyone.